structure of an atom. Ionization. Atoms are generally neutral. If an atom loses electron, it is left with a positive charge. It is called a positive ion or a cation. It is called a cation since it is attracted to the cathode. Examples are metals. If an atom gains electron, it is left with a negative charge. They are called as negative ions or anions. They are called anions because they are attracted to the anode. Example, nonmetals. This losing or gaining of electrons to form an ion is called ionization. The energy required to remove an electron from its orbit is called binding energy. It depends on the atomic number and the shell from which it is removed. Binding energy is greater for higher atomic number elements and it is greatest for the K shell. As you can see, for higher atomic number elements, the number of protons in the nucleus is very high. So, the attractive force will be more, which makes it difficult to remove an electron from its shell. And for the K shell, it is the closest shell to the nucleus, which in turn also increases the attractive force of the electrons in the K shell. This also increases the binding energy of these electrons to the nucleus. Now, the binding energy is always negative as energy must be supplied to the atom to remove these electrons. We should give them energy. So, it is negative. If energy is given to an atom, like the atom is gaining energy, it is said to be excited. It has excess energy. So, it is positive. For example, for moving an electron from a K shell to a shell of an hydrogen atom, the energy required is the binding energy of L shell minus the binding energy of K shell, which gives us negative 3.4 electron volt minus negative 13.5 electron volt, which is 10.1 electron volt. Neutrons and its properties. As we discussed, neutrons were discovered by James Chadwick in 1932. When beryllium was bombarded by alpha particles, he observed highly penetrating radiation was emitted with a mass nearly equal to proton but has no charge. The mass of a neutron is slightly greater than that of proton. Since it has no charge, it cannot be affected by electric and magnetic fields and can easily penetrate into other nuclei. All the atoms or nuclei in the periodic table has a neutron except for hydrogen. Neutrons are stable inside the nucleus, but outside the nucleus they are unstable. The half-life of a neutron outside the nucleus is 13 minutes. The number of neutrons is greater than the number of protons in a heavy nuclei. This will be discussed below in nuclear stability. Neutrons with energy ranging from 0 to 1000 electron volts are called as slow neutrons, and the energy ranging from 0.5 to 10 mega electron volts are called fast neutrons. And the neutrons having energy matching their surrounding atoms are called as thermal neutrons. Next, we'll look into nuclear structure and stability. The nucleus also has a shell structure like the electrons. The nucleons are arranged in these discrete energy states. The stability of a nucleus depends on a certain combination of protons and neutrons. That is the N by P ratio, neutron by proton ratio. A stable nucleus needs N by P ratio of about 1.5. That is, it should be between 1 and 1.5. This shows that the neutrons are greater in number than the protons. Low atomic number elements, that is, atomic number less than 20, are called lighter elements. In these, the number of neutrons is equal to the number of protons, that is, N by P ratio is 1. These are stable. In high atomic number elements, that is, atomic number greater than 20, these are called as heavy elements, mainly atomic number from 20 to 83. In these elements, the number of neutrons is greater than the number of protons. That is, N by P ratio is greater than 1. In these heavy elements, the number of neutrons is greater than protons in order to maintain the nuclear stability. We'll see how. In these elements, the large number of protons present in the nucleus causes a large repulsive force between them, which can make the nucleus unstable. So what we told before is the number of neutrons is more than the number of protons. This is to overcome this repulsive force to keep the nucleus stable.